Hello! We already know what the weight of evidence is. It shows to what extent a category of an independent variable differentiates between the categories of an outcome of interest or a dependent variable. To put it in a different way, weight of evidence shows how much information a category of an independent variable brings with respect to explaining the dependent variable. Weight of evidence gives us an insight into how useful a given category of an independent variable is. Of course, that would not matter if the original independent variable was useless to begin with. We can use the weight of evidence to find the answer to this more fundamental question. Assume an original independent variable has been split into categories. It may have been categorical originally, or categories may have been determined through fine classing or coarse classing. It doesn't really matter. Suppose there are k categories of this variable. Then, we can calculate the weight of evidence for each of the k categories. We already know how to do that. From there, we can weigh these weights of evidence of each category. We can weigh each by the difference of the proportion of goods from the total number of goods that fall into the respective category and the proportion of bads from the total number of bads that fall into the respective category. Then we simply sum them to reach a weighted average of the weights of evidence of the k categories. The result is called the information value of the original independent variable with respect to the dependent variable. Okay, the information value shows us how much information the original independent variable brings with respect to explaining the dependent variable. Therefore, the information value can be used to identify the original independent variables which explain the dependent variable best. Hence, as you are probably anticipating, you can use information value for preselection. So, if we have 100 contesters for predictors in a regression, the information value can help us preselect the best 5 or 10 or 20 independent variables to include in a statistical model. The information value is always in the range from 0 to 1. Greater values mean that the original variable yields more information with respect to the outcome. This metric is commonly interpreted as follows. A value lower than 0.02 means that the independent variable is not useful for prediction of the outcome. A value between 0.02 and 0.1 means it has weak predictive power. A value between 0.1 and 0.3 means its predictive power is medium. A value between 0.3 and 0.5 means it is strong, and a value greater than 0.5 means it has a suspiciously strong predictive power, or, in other words, that it is most certainly too good to be true. In this course, we won't use information value for variable selection, as we will opt for more advanced methods. Nevertheless, we'll try to calculate it and interpret it for each independent variable. Information value is a very important concept. It is widely used in credit risk modeling, so you should be very well acquainted with it. Once we are done with the course, you can try creating a credit risk model where you pre-selected the predictors using the information value. To wrap the topic up, let's see how information value is calculated in practice using our previous example. We have already calculated the weight of evidence for each of the two categories of the education variable. They are 0.51 and minus 0.13. Now, let's calculate the weights that we must use for weighing weight of evidence. So, for the higher education category, this is the difference between the proportion of good borrowers who have higher education and the proportion of bad borrowers who have higher education. So, 0.1. Analogically, for the no higher education category, this is the difference between the proportion of good borrowers who don't have higher education and the proportion of bad borrowers who don't have higher education. We get minus 0.1. Next, let's multiply each weight of evidence by the weight we just calculated and sum up these two products. The result we get back is 0.064. It is the information value of the education variable. Using the selection criterion we mentioned a minute ago, this information value indicates that having a higher education or not has relatively weak explanatory power. However, it is significant with respect to being a good or bad borrower. Well done! See you next time. Thanks for watching.